So, start your Arduino IDE. By default, it starts with a blank page, but what I want to do is to pick up one of the example sketches. So go to File, Examples, Basics, and choose Blank. So that way we're not going to have to type anything. Now first, I want to make sure that my circuit works the way that it's assembled. So I'm going to go ahead and upload the sketch to the Arduino. If everything works out okay, then I'm going to explain the different parts of this very simple sketch, so you know what's happening. I'm going to plug that into my Arduino, and the other side is already connected to my USB port. Now, a good practice is to first check to make sure that you have the correct serial port chosen, so that the Arduino IDE knows where to send the sketch to. So in my case, it's this device here. If you are on Windows, then you're still going to get a USB port, but the terminology used in Windows is going to be different to the Mac, but it doesn't matter. Just look for a USB port that corresponds to your Arduino. So choose that. And another little thing I need to change is to change LED 13 from the default sketch, make that 9. And I'll do the same thing with the comments in here. So I made two little changes. One's in the comments, and then one in the in this line here where I define the pin to which the LED is connected. So it's going to be 9 instead of the default 13. That's all there is to it. Now click on this button to have it uploaded. And there you go. You've got a bright red LED blinking on and off. Let's have a look at the sketch now. Now, every Arduino sketch has got a few components that are always going to be the same. I'm going to get started at the very beginning. So have a look at this piece of code. Notice how it's enclosed between a / and a star. And then at the other end, you've got a star /. So this is one way of inserting comments into your sketch. So comments are things that the compiler is not going to try to compile and translate into binary code. It's going to completely ignore it. So comments like that are really meant for humans to read, not for the computer. So one way of doing comments is to put them inside the / star / at the other end, or to use 2 / with the comment following the 2 / So if you use this method, then you can only put in, say, one line of comments. If you use this method, you can have multiple lines of comments. So comments, very, very useful if you want other people to easily understand what you're doing. Even sometimes yourself, you go back to a sketch that you wrote a few months ago, and having a comment there to guide you with what you did back then is helpful. Now the code really starts here. What we're doing here is to declare a variable, and we give a name LED, and we say that this variable is of type int. That's an integer. So LED is going to contain a number. We also give it the number that we want to store against this LED variable, and we're saying it's going to be 9. Right? Don't forget that always end your statements in this language using the semicolon. Right? There are other types of variables that we're going to see later on in this course, but int is very common, and int, if you're interested, you should know that it occupies 2 bytes in the Arduino's memory. Now, every Arduino sketch will have, at the very least, one setup method and one loop method. So the setup method, we just basically set up everything that the Arduino needs to know before it actually starts executing the code in the loop method. So the only thing that we're doing here is to instruct the Arduino to configure LED port which is in pin number 9, to be an output. So this could also be an input. We'll see in a couple of lectures from now that we're going to do an example where we take a reading from one of the pins on the Arduino. So instead of saying output, there we would say input. So always a good idea to configure the pins in the way that you want them to interact with their environment, either an output or an input. So that's it with the setup. In the loop, so the loop is a function where whatever you put inside the two brackets, opening and closed brackets, the Arduino will be executing again and again and again in a loop as fast as it can. This is meant to never basically stop until you turn the power off to the Arduino. So that's typical of microcontrollers. Microcontrollers tend to do the same thing millions and millions of times, right? So whatever we want them to do repeatedly will go inside a loop. So the first instruction that is executed inside the loop is digital write. So then we're saying to the Arduino, go to LED pin 9 and write a high value to it. High value means that the Arduino is going to send 5 volts through pin number 9, and those 5 volts will have the effect of turning the LED on. Then we are inserting a delay. Because we want the LED to stay on for 1 second, we use the instruction delay. We pass the parameter 1000. 1000 means 1000 milliseconds. So the LED is going to stay on for 1 second. Then we want to turn the LED off. So what we do is we say to the Arduino via digital write, go to LED 9 and change whatever value you had there into low, which for the Arduino low means 0 volts. So it's going to change the state of pin number 9 to 0 volts, and that's going to have the effect of turning the LED off. And we're going to wait for another 1000 milliseconds. That's another second. And repeat the whole thing all over again. LED is going to go on, wait for 1 second, turn the LED off, wait for another second, turn the LED on. So, there you have it, your first Arduino circuit and a blinking LED. Well done. In the next lecture, we'll make the same LED using the exact same circuit to fade on and off, giving us a much nicer visual effect to look at instead of blinking abruptly on and off. We'll see that much of what the hardware does depends on the software that runs in the microcontroller. So, see you in the next lecture.